Okay, so this time we are going to solve a system of 3 equations in 3 variables using substitution. Now, of course, substitution means to substitute something of equal value. So we need to know what something equals in order to substitute. So what I'm going to do is I'm going to look at one of these equations, and I'm going to take the first equation up here, and I'm going to see that I can solve this equation for the letter z. I'm going to do that very simply by subtracting 2x from the left side and subtracting 7y from the left side. And that's going to leave me with z equals negative 53 minus 2x minus 7y. Now that I know what z equals in the first equation, I'm going to come over here to my chart and I'm going to circle z because I know what it equals. And that means I've solved for z in my first one. And what I want to do with that is I want to replace the z in the second and third equation. So I'm going to not have a z over here anymore, and I'm not going to have a z in the third equation anymore after I'm done substituting. So let's see what that looks like. It's going to say negative 2x plus 3y plus, and then here's the substitution. In replacing the z, I'm going to replace it with negative 53 minus 2x minus 7y. And that's, of course, going to equal negative 13, like it says. And before I solve that, I'm going to replace the z in the third equation so I don't forget to do that. So we're going to have 6x plus 3y plus, and then replace it with negative 53 minus 2x minus 7y, and this one equals negative 45. So you can see that I now have a second equation right here and a third equation right here, and neither one of those equations has a z anymore. And I can see that up here in my chart. I've scratched out the z in the second and third equation just to keep track of what I'm doing. The next thing I'm going to do is I'm going to simplify both of these equations. So because there's nothing to multiply by, I really don't need these parentheses. I'm just going to combine like terms. So I'm going to take the negative 2x and combine it with the other negative 2x to make negative 4x. And then I'm going to take the 3y and combine it with the negative 7y. 3 minus 7 is negative 4y. And instead of writing a negative 53 on the left side of the equation, I'm going to go ahead and add 53 so that it can combine over here with the negative 13. That way I have an equation in standard form, and I can work a little bit easier with that. So negative 13 plus 53 is 4. And I'll go over here to this side, and I'm going to combine the 6x and the negative 2x. We're going to have 4x. We're going to do the 3y minus the 7y. We're going to have negative 4y. And then we're going to this time add 53 to both sides. And if I add 53 to both sides to get that over here, negative 45 plus 53 is 8. Okay, I'm looking at 2 equations, 2 brand new equations with 2 variables. Both of them have an x and a y. I'm going to start the process over. I'm going to pick one of those equations and I'm going to solve for one of the letters. So I'm going to just come over, let's do this third equation right here. And I'm going to solve the third equation for x. So I'm going to go up to my drawing here and I'm going to circle the x in the third equation. I'm going to solve for that one. Okay, so that means I've got to add 4y to both sides. So we're going to have to add 4y over here. And then I'm going to divide everything by 4 so that I can get the x by itself. And so that's going to be x. 8 divided by 4 is 2. And 4y divided by 4 is just going to be y. We now know what x equals. So back up to my drawing up here. We're going to replace the x in this second equation, leaving no more x's. So we're going to have negative 4 times, and we know x equals 2 plus y. So we're going to replace the x with 2 plus y minus 4y, and that equals 40. Now we have one equation with only a y. That's the second equation with only the y, which means I now know what y equals as soon as I solve this. So negative 4 times 2 is negative 8 minus 4y again equals 40. Combining the y's, you get negative 8y. Okay, and adding 8 to both sides gets you 48. I can solve this by dividing both sides by negative 8, which would be y equals 48 divided by negative 8, which is negative And so we know y equals negative 6. And I'm going to put a box around it so I can find it easier. I know here y is negative 6. I'm going to just mark that right there to help me remember. Okay, now that I know what y is, if I look over here at my drawing, I can replace the y right here in the third equation with negative 6. And that would allow me to find what the x is. So I'm going to take the y in this equation, and I'm going to replace it with a negative 6. So plus negative 6 right there. And the plus and minus make it just 2 minus 6. 2 minus 6 is negative 4. So we also know that the x is negative 4. I'm going to mark that up here so I can keep track of it. Now I know what the x and the y are. If I look at the first equation, I can replace the x with a negative 4. And I can replace the y with a negative 6. And that would help me solve for z. So I left a little space up here so that I can do that. Here's the first equation. We know z equals negative 53 minus 2. Here's the x, and x again is negative 4. Minus 7 times negative 6. Z equals negative 53. And then negative 2 times negative 4 is plus 8. Negative 7 times negative 6 is plus 42. Well, let's combine these two first. That's easier. 8 plus 42 is 50. So negative 53 plus 50 is negative 3. And so we know z is negative 3. Okay, if I want to write my answer as an order triple, then I would put the x, then the y, then the z. I can prove my answers are correct by taking all three and plugging them into each one of these letters. And if I plug in the x, the y, and the z and compute this, it will equal negative 53. The x, the y, and the z here would make it equal negative 13. And the x, the y, and the z here would equal negative 45. This video was long enough, so I'm not actually going to write all that out. But I hope you had fun learning how to solve a system by substitution. Woohoo! Peace.